Welcome to Transitional Algebra. This class is going to be getting you ready for college algebra. We're going to learn a lot of things this semester. In Chapter 1, we're going to start out in Section 1, solving equations. So our objectives are going to be determining whether a given number is a solution of a given equation. We want to be able to solve equations using the addition principle, solve equations using the multiplication principle, solve equations using addition and multiplication principles together, and removing parentheses where appropriate. A blank is a number sentence that says that the expressions on either side of the equal sign represent the same number. Well, what is that going to be? Right. So it's going to be an equation. Okay, determine whether the equation is true, false, or neither. Okay, so what you want to do is you want to look at this and you want to see, does it make sense? Well, 4 plus 6 is 10. There's nothing we can do to this side, so obviously 10 is equal to 10, so this is true. 8 minus 3. 8 minus 3 is 5. There's nothing we can do to this side, it's just 4. 5 is not equal to 4, so this is false. In math, I cannot just leave that there saying equal. We draw a line through it to represent not equal. X plus 9 is equal to 21. Well, we don't know what x is, so before when we could figure out 4 plus 6 and 8 minus 3, we found an answer. We don't know what x plus 9 is because we don't know what x is. So this one is a maybe because we need to know what is x equal to. The replacement for the variable that make an equation true are called the blank of the equation. Okay, so if it makes the equation true, it's going to be the solution. The set of all solutions is called the solution set. When we find all the solutions, we have solved the equation. So here's an example. It says determine whether 8 is a solution of x plus 12 equals 21. So if we've got x plus 12 is equal to 21, what we want to do is we want to take that 8, we want to plug it in for x. Is 8 plus 12 equal to 21? 8 and 12 is 20, and 20 is not equal to 21, so 8 is not a solution. It doesn't work. Equations with the same solutions are called equivalent equations. Okay. The addition principle for equations. For any real number a, b, and c, a is equal to b is equivalent to a plus b is equal to b plus c. So basically what they've done is said, well, we already know that a and b are equal to each other. So if we take the exact same number and add it, then it should be. So a lot of people are confused by whenever we add letters to math, but I could show you an example. So we're saying A is equal to B. So in numbers, we could say, well, 3 is equal to 3. They would have to be the same thing. And so if we picked a C, let's say it's 2, then this would be 3 plus 2 is equal to 3 plus 2. And of course, that's true. So they want us to solve an example using that principle in algebra. So there's lots of different ways that people document how they do an algebra problem. If you have a method that works well for you and you want to continue doing that, that's fine with me. This is the easiest way that I can show you the addition principle, because what we want to do is we want to get x by itself, so we need to get rid of a plus 6. Well, the only way I can get rid of a positive 6 is to subtract 6. And if I subtract, because 6 minus 6 is going to be 0, and if I subtract 6 from this side of the equal sign, our principle up here says we've got to do the same thing to this side. So, and since we're calling it the addition principle, I'm going to say, well, x plus 6 plus a negative 6 is equal to negative 9. So the only thing that changes, I'm adding a negative 6, so I've got to add a negative 6 to this side. Well, this and this turns into 0, and I'm just left with x. On this side, I've got negative 9 plus a negative 6, which is going to be negative 15. Okay, I can plug that back in to my problem over here. So I'm saying x is negative 15. So is negative 15 plus 6, is it equal to negative 9? Negative 15 plus 6 is negative 9. So when we go back and check our work, we know that we're correct. Okay. In this example, we've got negative 8.3 is equal to y minus 17. Sorry. 17.9. Okay, so this time I'm trying to figure out what y is, so I want to get rid of a minus 17.9. Well, if I'm going to use the addition principle, I'm going to need to make this turn into 0. So negative 17.9 plus 17.9, that is going to turn into 0. But if I add a 17.9 to this side of the equal sign, I'm going to have to do the same thing over here. So negative 8.3 plus 17.9. Okay, these are going to cancel out, and I'm going to get y is equal to negative 8.3 plus 17.9 9.6. Okay, and if we plug 9.6 up in here for y, 9.6 minus 17.9, we would get negative 8.3. So there's another principle that we can use in algebra, and it's called the multiplication principle. So basically, if we have two numbers or three numbers, a, b, and c, as long as c is not equal to 0, if a is equal to b, then we can multiply a and b times the same number and we will get the same answer. So that would be like saying 3 is equal to 3. That would be our a is equal to b. Then let c equal 2. So is 3 times 2 equal to 3 times 2? Yeah. This is 6. This is 6. So that's going to work. So how do we implement this when we're using algebra? So our first example, we've got 3/4 x equals 15. I really need to get rid of this fraction, and there's a couple ways that I can do it, but we're going to use the multiplication principle, and so the only way that I can get rid of that is for this number to turn into 1. And when you multiply by the reciprocal, which is just basically the number flipped upside down, And whatever I do on one side, I've got to do on the other side. What's going to end up happening is 4 times 3 is 12, 3 times 4 is 12, 12 over 12 is just 1. So these things end up canceling out, and we would get x is equal to 15 times 4, because on the bottom of this 15 would just be a 1, right? 15 times 4 is 60 over 3, and 60 divided by 3 is 20, okay? Well, what is 3/4 of 20? If you have a $20 bill and you've got 3/4 of it, that's 15. So we did good. Okay, 6x is equal to 96. Now, I'm supposed to use the multiplication principle. So I need to get rid of a 6. The only way I can get rid of a 6 is to multiply by 1 over 6 or divide by 6. Because what's going to happen is 1 times 6 is going to give me 6 on the top. Let me just draw, thinking about this. So we've got 1 times 6 is going to give us 6. And on the bottom, we would also have 6 times 1, which is 6. 6 over 6 is just 1. And 1x is just x. Okay, and on the other side, we've got 96 times 1 over 6. Okay, then we would need to do 96 divided by 6 to find out exactly what the answer is. Okay, and it's going to be 16. Okay, we've got negative. We have negative 7x equals 84. Okay. I really don't like to teach. I mean, we could multiply both sides by negative 1/7, but it's easier just to divide here. So I would say divide both sides by negative 7 when you have something like this, because negative 7 over negative 7 is 1. That's going to cancel out. 84 divided by negative 7 is going to give us negative 12. And we could plug our negative 12 in. Negative 7 times negative 12, just to make sure we got it correct. It is equal to 84, so we are right. Okay, now we've got 9 plus 8x equals 33. So we've made it a little bit more complicated. So we've got to get rid of the 9 and the 8. Always, always, always get rid of the thing that's not connected to the letter first. Okay, so this 8 is connected to the x. The first thing we want to do is get rid of this 9. Okay, the only way we can get rid of this positive 9 is we can add a negative 9 to both sides, which is the same thing as subtracting 9. Okay, those are going to cancel out. I'm going to be left with a positive 8x. We don't need to put that there. We know it's positive. Is equal to 33 plus negative 9, and 33 plus negative 9 is going to give me 24. Okay, now how do I get rid of 8 times x? I'm going to do the opposite of what I was doing. Instead of 8 times, I'm going to do divide by 8. These are going to turn into 1. So we've got x is equal to 24 divided by 8, which is 3. I could go back up here and make sure by plugging in the 3 for x that I'm on the right track. Remember, in order of operations, you want to multiply before you add. So 8 times 3 is 24 plus 9 is 33. So we did good. Okay. Now we're getting a little bit more complicated. We've got things that we want to do on both sides of the equation. And this is an equation because it has an equal sign. So the first thing you want to do when you have all of this is you want to see if you can combine like terms, okay? The 4x and the negative 6x are what we would call like terms. They would go together. So we would say, well, what is 4x minus 6x? That's negative 2x plus 7, right? We still have our plus 7 on that side. Any like terms over here? Well, there's nothing to go with the 3x, but the 10 and the 12 are just regular numbers. Those are like terms, and 10 and 12 would add together to be 22. Okay, so we combine like terms. Okay, the next thing we want to do is we want to get all of the variables on the same side of the equation. So it doesn't really matter which side you move things on, but I either need to move this negative 2x over to this side, or I need to move the 3x over here. To move the negative 2x, I would add it, and I would much rather add than subtract. So I'm going to go ahead and say 2x minus 2x plus 7. So all I've done is added on a 2x. But if I do that on this side, I've also got to do 2x plus 3x plus 22 on this side. These are going to go away because 2x minus 2x is 0. This is going to turn into 5x plus 22. Okay, now we're to the point where you go to the side with the variable on it, because we've got the variable on one side, and you want to get rid of the thing that's not connected to the x first, which is going to be our plus 22. So to get rid of a positive 22, we're going to need to subtract 22. Well, if we subtract 22 on that side, we've also got to do the same thing over here. 7 take away 22 is negative 15. We've got 5x. These cancel out into 0. Now we've got 5 times x. That's all we have to get rid of. We want to divide by 5. So these 5's cancel out. Negative 15 divided by 5 is negative 3. Okay. And we could plug it up and check. We could plug up that 3 every time we see an x, and we could check and make sure that we are correct if we want to. Let's just go ahead and do that. Never a bad idea to check your work. So all I'm doing is every time I see an x, I'm putting in the negative 3 that I got, just to make sure that I got the answer right. So 10 plus 3 times negative 3 plus 12. So I plugged in a negative 3 for this x, and for this x. Okay, well that's negative 12 plus 7 plus 18, because we've got a negative times a negative. 3 times negative 3 is going to give me negative 9 plus 12. Okay, negative 12 and 7 is negative 5. Negative 5 and 18 is 13. Okay, and on this side, I've got a 10 minus 9. 10 minus 9 is 1, and 1 plus 12 is 13. So we did a good job. Okay. Here's another example. Okay, so it looks to me like first step is combine like terms. There aren't any. Next step is try to get all your variables on one side. Well, I already have that. So then we want to start getting rid of the thing that's not connected to the letter. So we want to go to the side with the letter and get rid of the 18.4. Well, a negative 18.4 is all that I'm going to have to put that on there to get rid of a positive 18.4. So I'm going to subtract 18.4 from both sides. This is going to cancel out, and I'm going to get negative 6.2y on this side. On this side, I'm saying 7.24 minus 18.4. That's going to get me negative 11.2. 16. Still, I've got something in front of that variable and I'm multiplying. So the opposite of multiplying, dividing, is what we're going to want to do to get rid of that negative 6.2. Divide, those cancel out and turn into 1. Okay, and negative 11.16 divided by negative 6.2 ends up being 1.8. Okay. First step, combine like terms. On this side, I don't see anything I can put together. On this side, there may be something I can put together, but it looks like there's a little bit of work for me to do here. So I'm just going to write this side down. 6 is fine, but I need to use something called the distributive property to get rid of those parentheses. In the distributive property, you take the number in front of the parentheses and you multiply it by both of the things in the back. So 8 times x would be a positive 8x. 8 times negative 3 would be a negative 24. Okay? So I got rid of the parentheses. Now, combine like terms. Nothing on this side for me to combine. But the 6 and the negative 24 could go together. 6 minus 24 is negative 18 plus 8x. Then I want to see, okay, I need to get rid of variables that are on both sides. So I'm either going to have to move this 8x or I'm going to have to move this 8x. So if I subtract 8x, because it's a positive 8x, I would have to do the same thing, and let me be consistent because we've been going across. So if you want to go down, which is, I have a tendency to do that, but I'm going to say negative 8x plus 8x minus 18 equals negative 18 plus 8x, and since I subtracted 8x over here, I've got to subtract 8x over here. Well, these cancel out, and these cancel out, and that's weird. I'm getting negative 18 is equal to negative 18. Okay, that's strange. But I'm glad we did this problem because this one has infinite solutions. Okay, what that means is I could plug in anything for x and it would work. Okay, it has infinite solutions. If we had gotten to the bottom and our variables canceled out, which sometimes they will, and this statement is not true, then we would have no solutions. Okay, so we have infinite solutions because the x is canceled out, which means everything is going to work and this statement is true. Okay, so looking at this, you should realize that you've got to get rid of those parentheses first. You're going to have to use the distributive property. Take that negative 4. We're going to multiply it by both things in the parentheses. Negative 4 times x would be a minus 4x. Negative 4 times 6 is negative 24. Do the same thing with this negative 4. Negative 4x, negative 4 times negative 1. Well, negative times a negative becomes positive 4 minus 3. Okay? Got rid of the parentheses. Then we want to combine like terms. Well, on this side, the 3 minus 24 could go together. 3 minus 24 is negative 21. Okay, the 4 minus 3 could go together. Negative 4x, 4 minus 3, positive 1. Now we can't have variables on both sides, so we want to either move this minus 4x or move this minus 4x, and we're going to do it the same way. To get rid of a minus 4x, we're going to have to add 4x. If I add 4x to this side, I've also got to add 4x to this side. Well, that turns into 0, so I have negative 21 is equal to 1. Well, no, it's not, right? Okay, So this one has no solutions, which means I could plug in, there's no number that I could plug in for x that's ever going to work, okay? Doesn't happen because this is not true. The one above it, remember, was true. When we got those x's to cancel out and go away, it has infinite solutions. I could plug anything in, it would work. But when you get one that's not true, nothing's going to work, okay? Here we go. We want to solve this problem, so we know we want to use the distributive property and multiply that -8 by both things. We want to also do the 4. So we've got 3. -8 times x is -8x. -8 times 6 is -48. 4 times x, 4x. 4 times -1, -4 minus 5. Combine like terms. Well, the 3 minus 48 will go together. 3 minus 48 is -45. Still have the minus 8x on this side. -4 minus 5 is -9. Now, we combine like terms. Now we want to get all our x's to one side. I would rather add than subtract. So to get rid of a -8x, you would add 8x. So that's what I'm going to do. But if I add 8x on this side, I've got to do the same thing over here. These are going to cancel out. I would get -45 on that side. 4x plus 8x, that's 12x minus 9. Okay, we're getting closer. We got to go to the side with the x on it and get rid of the thing that's not attached to the x. So I'm going to say we could, to get rid of a -9, we could add 9. But if we do it on that side, we also have to do it over here. So that's going to be -36 equals 12x. I do not know what I just did, but this should be a 9. Sorry about that. Just in a hurry, I guess. Okay, and we go to the side with the x on it. It's 12 times x. The opposite of multiplying is going to be to divide by 12. And so we get x is equal to -3. Okay. And remember, you could always plug in that -3 up here and work it out and make sure that it's equal on both sides. Okay. Here is in the notes a short method for solving equations. So it's up to you if you want to use it. But it says clear the equation of fractions or decimals if that is needed. If parentheses occur, multiply or remove them using the distributive law, which that's what we did. We didn't clear the fractions or decimals, but that's not a bad idea. You could work the problem without doing that. Collect like terms. So remember, we would clear the parentheses. We collected like terms. Then we use the addition principle to get all the like terms on letters on one side. And then we use the multiplication principle, and a lot of times we would divide to clear out whatever was in front of the x. Okay, so that is section 1.